scientific notation. So scientific notation is used for really big or really small numbers, so we can write the numbers down more concisely. So for example, if I had a big number like 93 billion, in scientific notation, I would rewrite that as 9.3. There's always just going to be one digit to the right of the decimal. And then everything else goes on the other side of that decimal. And I have my right and my left messed up as usual. Left. Yes. And then we multiply by a power of 10 to make this whole thing equivalent to that. So the decimal point was over here. To put it here, I had to move it 3, 6, 9. One more place would be 10. So 93 billion would be the same thing as 9.3 times 10 to the 10th power. The 9.3 in scientific notation is known as the Mantissa. And then we have this, what they call the characteristic power over here. I'm just going to call it the power. On a calculator, sometimes that'll look a little different. So if you do a calculation on a calculator, it might give a slightly different version of scientific notation. Let me think. I think the Google calculator might do that. So I took that 93, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I were to multiply that by 1,000, that will probably trigger the calculator to use its version of scientific notation. So I just multiplied by 1,000, which is going to give me a bigger number than I had originally, and notice the calculator says E plus 13. So that's, some calculators display that in different ways. So I took my 9.3 times 10 to the 10th. So that was my original number. I multiplied that by 1,000, and the Google calculator said that was 9.3 E plus 13, right? Now, if we look at what I have here and what I have there, well, 1,000 is really 10 to the 3rd power. If you multiply things with the same base, you get the add the powers. So this should be 9.3 times 10 to the 13th power. And so this calculator notation is pretty common. You'll either see a little e like that, but usually you'll see a bigger e, 9.3 big E. And then sometimes it'll be just a 13, sometimes it'll be a plus 13. So that e just means exponent 13. The base is assumed to be 10. So that just means the same thing as that right there. So this is saying, hey, exponent. And we just assume the base is 10. Excuse me. And 10 is the most common base when we're playing around with numbers because we have a base 10 number system. So some calculators, again, might have a big E, some have a little e. That's just the calculator version of it. Sometimes spreadsheets show that notation too, if you do big numbers on a spreadsheet. So we can also use scientific notation to do really small numbers. So remember, numbers like 1/10, whether in decimal or fraction form, 10 to the -1 means flip the base. So 100th is 10 to the -2. So we can also use scientific notation for really small numbers. So if we had a number like 0.0000576, and I want this to be in scientific notation, well, I would want the decimal point to be between the 5 and the 7, so I can only have one digit to the left. The Mantissa is always going to be between 0 and 1, and it's going to be greater than 0, but it could be less than or equal to 1. And then I have to adjust by multiplying by a power of 10. Now, since this is a small number, that's going to be related to its place value, right? Tens, hundreds, thousands. So 10 to the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, moving that decimal 1, 2, 3, 4, 5, 6. That should be 10 to the negative 6th, right? 6 right there. So scientific notation, my hope is you've seen it before, so this should just be a brief refresher on it. It's for really big and really small numbers. And so I just have a few homework problems, just kind of remind you of what it's like to work with scientific notation. And so it's pretty much, can you put a number in scientific notation? Can you take a number that's in scientific notation and write it as a regular decimal? And then a couple of examples of scientific notation in use. And then, you know, the big uses, what kind of big numbers do we work with? Well, big numbers would be related to stuff about the solar system and the galaxy, so like astronomy type stuff. Big numbers pop up. If we're talking about, like, we have this big bill for the coronavirus coming up and they're talking about trillions of dollars, right? That's billions of dollars. They're talking about trillions of dollars needed to try and help the economy. So national budgets, these enormous numbers. And then the smaller numbers come into play all kinds of places, right? The size of a virus, pretty small. That's going to be in terms of meters, scientific notation, nanotechnology, super small things, a little above the atomic scale, though. Anytime we have something really small like that, we're going to use scientific notation. It's a little more efficient than writing out all of those zeros there. So just a quick review on that. And then, oh, I see something popped up in the chat. So that's really what I want to say about scientific notation there. It's a pretty short part of this section.